Good morning or good afternoon, depending on where you're joining us from, and welcome to today's webinar. I'm Cess, your moderator from BTMI, and it's truly a pleasure to have you all here. We're delighted to have our wonderful sponsor, ABB Motion High Power, with us today, who'll be presenting this webinar titled Powering the Energy Transition. Let me introduce our esteemed guest speakers for today. Today, we have Luca, Industry Sales Manager, and Jari, Sales and Marketing Manager at ABB Motion High Power. Now, before we dive in, let me quickly walk you through our webinar platform. This webinar is browser-based, so if you get disconnected, just click the link in your email to rejoin. Today's webinar is being recorded, so you'll be able to watch it on demand later. If you have any questions during the webinar, we'd love to hear them. Simply type them into the questions widget at the bottom of your screen and click submit. We'll save some time at the end for a Q&A session to go over your queries. Don't forget to check out our related resources widget for more helpful materials. And after the webinar, we'd really appreciate it if you could take a moment to fill out our survey to share your feedback with us. And if you need any technical assistance, the help widget is available to support you, and you can also resize or maximize any of the windows on your screen for a better view of the slides. And now, without further ado, let's give a warm welcome to our first speaker, Luca.
Thanks a lot, Cess, for the nice introduction. Hello also from my side to all of you. Maybe a few words before I start. My name is Luca Rizzo. I'm based in Italy, and I'm looking after three industries, so water, power, and data center. Today, we will mainly talk about power industry. And today I'm not in Milan, so I'm talking for a little bit far away. So I'm based today for this session in India. But okay, I think everything is worked well. So let's move to start this slideshow. Okay, this is the agenda for today. With me, you are going to mainly look after the power landscape. So we talk a little bit about the main power trends. And then we will touch a bit of what are the application, but also the sub-segment in the power industry where the reliable power is really needed. Then we move with my colleague Jari, and we talk more about the ABB generator portfolio. We then focus, let's say, the most technical part, going more into details for modular synchronous generator. And then we have the last part where we really do comparison on using different type of generator and different level of efficiency. What does it mean at the end of the day for the operational cost? And then to conclude, a key takeaway message, so a brief summary to the main content that we want to share with you today. Okay, so let's start with my part. So like I was saying, we are going to touch the market landscape. So let's move to the slide with the content. Here, there is a lot of report around about the market trend. I select the one from global data that I think is very good source of information. And I think the message here, the main message is clear that the power generation market is really growing, and it's not a growth that is going to be happening in 1-2 years, but it's supposed to grow for at least 10 years, but probably also more. And the point is also that this growth it's pretty important. So some evaluation we take is probably the market going to grow more than 4% year on year, and this is really unbelievable. When it comes what is going to drive this growth, I think we know pretty well also from the information, the news, but also the political discussion. Renewable will be probably the main driver for the growth. I want to give you some number because I think this can help also our discussion. I think 2027, based on this number, but it could be also 2028, we are going probably to have that the capacity of renewable will surpass, the capacity that we get from the fossil fuel. This is something unbelievable if we go back, 5 to 10 years. And the solar is probably the one source that is really going to boom. The growth level is more than 10%. So it's probably the source where the most of the investment is going to happen. Similar, wind, but let's say it's growing a little bit less than the solar. Probably the solar is really the biggest one. Wind is also following. So these two sources of energy will be probably the main driver of growth for new capacity. Then for sure, there are also the fossil. And to me, coal, it's a big discussion. Probably we are already reached the top of capacity and production from coal. Depends also by the country that we take in accounts. But I would say, in overall, we probably start to see some declining on the coal solution. And then probably today and in the next 5 years, gas will take over some of the production that coal will be dismissed. So gas will be one of the sources that we are going to use the most. And then the last topic that is also happening is connected to nuclear. So a lot of discussion regarding nuclear and discussion on how to extend the life of the existing nuclear power plant, but also a lot of discussion on SMR technology, this small modular reactor technology. So this can be also contribute to cover some of the power need, but most probably after 2030. Talk a little bit about what are the main topic. Okay, sorry, one second. Okay, now the slideshow is working. Okay, very good. So the demand, as I say, is very strong. So we are going to have a market growth of 4%. But which are the main reasons why the demand is so heavy and so strong? I think the main driver are mainly related to buildings. Think about how many investments are happening. A lot of in the buildings is also related to how we are going to heat, our buildings. Now it's mainly gas, but we have this big demand for heat pump. So a lot of energy is needed, electrical energy is needed. Transport, think about also the automotive business that, electric vehicle is getting most common. And the big part also is related to marine industry, where also electric propulsion is really taking the most. And then for sure also the manufacturing or the industry itself. A lot of industry are really moving more to net zero or less carbon source of information, of energy. So I think about, metals, I think about mining. So all this kind of industry change is really driving to move to more electricity need. We talk a lot about energy transition, but to me, it's not only energy transition, but it's also energy addition. So we have these two big things happening at the same time. Then, if we go a little bit more in the detail, what are really having big impact in the demand and in the industry, I think a data center, this is going to really have a big impact. A lot of investment is happening today in US, and we see clearly that they really affect the power generation of US country. So this is something that we probably need to take in account. And for sure, it will be, moving also outside US, Europe we see already, and Asia will follow for sure with big number. Then I spoke already about solar. So solar is the most growing source of energy, but there is some, I'm not saying issue, but for sure some challenging to connect so much power generated by solar. So because the grid is not, let's say, so new, and because we adding so much solar is really can bring if you don't do properly, can bring some unbalance on the grid. So this is a big question mark. We know there is a lot of countries that are adopting grid code requirements. So this is a clear challenge. So it's a matter. So we are going to invest a lot in solar, but maybe sometimes the grid is not ready, and also there is in some cases also political procedure or let's say bureaucratical procedure that is take much longer time to be connected. On natural gas, I already comment, so I think this could be a source of energy that is very fast to get, and a source that can really taking some of the contribution of coal. And this is, I think, there is a big push. You saw also in US a big push on LNG. And I think is the source of energy that give us much more reliable power today. Energy storage, this is another big, for sure, area. Different type of storage, could be battery, but it could be also pump storage system or pressure storage system. The point here is that I think improvement is there, but the point is how much are big the battery and how much they can keep the power on. So this is, I think, it's a big topic. I see the market moving in this direction, but also the point is how much is the capacity of this kind of set of battery. And the last point is more related, let's say, on the new tech or what we call clean tech. Hydrogen, a lot of discussion 2-3 years ago, but not really booming. Some project, I would say, now we start to see moving, real project, but the expectation was bigger. So this is a big question. But for sure, I see a lot of potential on blending, or mixing gas with hydrogen. This is something that we can use and apply also on existing turbine solution. Carbon capture is another big topic. Also, there's a lot of talks. Probably now we start to see real case, but also here I think that depends also on the push from political decision maker, how much they want to charge on CO2 emission. This is a big issue. And then I think an area that to me is also pretty interesting is the biofuel. So biogas, biofuel, it's really interesting area because changing a little bit the fuel, you can really save a lot of emission. Okay, so this was, let's say, the introduction. So I hope I was clear. The topic is very big, so to cover in a short time is not easy. But to me, the direction is clear. So renewable will be the main driver, but most probably, considering that is not only energy transition, but is also energy addition, we probably still need also some other source of energy. Okay, then to give you also a picture, I mentioned the data center previously as a big driver for power generation. And here in this slide, I was trying to give you an explanation why it's really going to happen. For sure, the artificial intelligence will drive a lot, the impact of data center. Maybe not for the number, but for the size. So nowadays, I think it's very common to talk about 25 megawatt data center, but I think there are a lot of companies that are already talking about 100 megawatt. And I see also some project that there are discussion to have a data center of 1 gigawatt. So very, very big, huge, install of data. The point for data center is that they are really mainly taking a lot of energy. So the point is how we are going to supply energy to this kind of buildings, because at the end it's a kind of buildings. So the point here is there is some discussion, and like I saying, there is case by case, also country by country. In US, for example, some state, they say you want to build a data center, then you should build your own power plant. So, the impact on the power supply will be there. This kind of data center we call island mode type, so because they are kind of independent for power supply. And this is really something that we will see coming more and more. And then another topic that is relevant for the industry is the reliability. So data center should be run always, 24 hours, 7 days, never stop. And you see also, I put the number on the reliability, 99.9999%. So we say 100% reliability. So this is, this kind of need from some of the market, to me, is really moving to the next slide. So to the fact that we probably need to think how we want to balance, let's say, our supply of the power. So before going to the, let's say, the description, I want that you maybe focus on the picture that I put there. So you see how I see the kind of smart grid concept. So you see the power generation coming from different source, so wind and solar, like we discussed. But then I put also conventional power generator. I put the energy storage system, and then the grid. So this is, to me, could be the ideal model that we should have. It could be applicable for microgrid. It could be applicable for data center. It could be applicable in a lot of places. But the point, the answer to me to this big demand on power is to have this kind of flexible system available. So you can be green when you have wind and solar, but then you can also have the conventional power generator that can offer you really, steady and continuous power supply when you need. And you can also apply the battery storage that can help you if you have, some problem for a little bit of time. So this is, I think, is the main concept, and this is also a big topic in the industry. How to balance, all the different source in a good way that I can offer, a good set of energy to this big demand. Okay, this was my part. I hope I was clear. So market is growing, demand is there, energy transition is happening, but also we need to be able to offer some energy that should be steady and continuous, also for some application that I really need this kind of energy. Okay, I can now leave the stage to my colleague Jari, and let's talk at the end for the takeaway message. Thanks.
Yeah, thanks a lot, Luca. Maybe I'll start also with introduction. So my name is Jari Mäenpää, and welcome also on my behalf to this webinar. I'm working as a sales and marketing manager at our motors and generators factory and based in Helsinki, Finland. So my responsibility is basically our slow speed generator portfolio, meaning in this context generators or alternators, depending how you call those, for engines. And I have more than 20 years of professional experience from the power industry, both on and offshore. And I'm now very happy to discuss here how our future-ready modular generator solutions support towards cleaner and more resilient power infrastructures, just like Luca mentioned in the beginning. But before diving into our latest innovation, I think it's good to say a couple of words about our portfolio for generators, because we are definitely not new in the industry. We have been here for more than 140 years now and delivered more than 100 gigawatts of power worldwide, basically. And annually, we deliver more than 1,000 generators globally for all applications. So power generation, oil and gas, offshore, marine, mining, you name it, we deliver to all industries. And of course, thus we have huge domain expertise from this generator application and solutions. And of course, as global company, we have worldwide service capabilities to support the lifetime and reliability of our products. Then if we quickly look at the portfolio, what we have, we basically produce generators, synchronous generators up to 70 MVA, and both low voltage and high voltage applications. Typical applications include a base load for power generation, power grids, balancing application, so related to this energy transition. This is increasing a lot in our portfolio. Peak saving, grid support. Let's talk more about that very soon. And then, as Luca mentioned, data centers, that's a growing business. So we produce critical power generators for that industry, and also the base power or primary power. And then critical backup power for different applications like hospitals and that kind of industries. But now let's proceed to, let's say, our latest innovation in the generator portfolio. We call this Modular Synchronous Generator. And what does it mean in practice? Well, basically, like Luca mentioned, the transition to renewables is setting new requirements for electricity grids and related grid codes as well. And a reliable power generation is essential to ensure that the grid remains resilient to disturbances. Therefore, this kind of conventional power generation will also transition towards new operation profiles and applications. And depending on the type of power plant, operational profiles can vary from short-term balancing to continuous power generation. And this ABB Modular Synchronous Generator is designed to meet these challenges. And basically, what modularity means, it means here that our designs can be produced to cover applications ranging from balancing of the grid with a high number of starts and stops every day, through intermediate load to continuous base load operation with requirements for high efficiency and inertia to support the grid. And in fact, this modular generator is so versatile that it can also be used as ancillary services, so balancing markets, or even be operated as synchronous condenser. So basically, this product is designed to meet the requirements of today and tomorrow. Then if we go a bit deeper to the technical details of this new modular synchronous generator, basically this is designed for 20 megawatt class engines. So meaning power range is between roughly 18 megawatts to 25 megawatts. Voltage is up to 15 kilovolts, and typical frequencies 50 hertz and 60 hertz. And what is basically the biggest innovation here is the capability to have flywheels here to increase the inertia. So basically that helps to comply with even the most demanding grid codes. Let's go through that in the next slides. And then the other topic is that this generator is capable of up to 4,000 starts and stops per year. So this is perfect for balancing applications and this kind of peak saving applications where you need to bring fast extra power to the network frequently. So main features is like mentioned, we can install 1 or 2 flywheels to increase the inertia, which ensures that the plant remains synchronized with the grid during the faults. Then we have also made a completely new cooling design for this machine, which means that there's roughly 60% of increased airflow within the generator. So this saves energy and enhances the efficiency of the machine, and of course makes the footprint of the generator also smaller than the traditional ones. And modularity, like I said, it means different applications, but also because we have modular designs like these flywheels and cooling units, it also means then fastest delivery times. And as the latest innovation, this generator is suitable for synchronous condenser use, which I will explain a bit more in detail in the coming slides. So basically, one of the most demanding grid code requirements is to stay connected when there's a low voltage or short circuit event somewhere in the grid. This generally requires the gensets to provide high inertia and fast response to ensure that the plant stays in synchronism with the grid when the fault is clear and voltage returns to nominal. To ensure this, we have basically came up with this solution to have a possibility to have increased inertia within the generator, because that's one of the key ways how to comply with these requirements, these sometimes quite long fault right-through requirements. So we have the option to add inertia on top of the rotor itself, 1 flywheel in the non-drive end of the generator and 1 flywheel on the non-drive end of the generator. So then the maximum inertia of this machine is something like 33,000 kg/m². So basically, with this solution, we can comply with basically any grid code requirement of today and tomorrow as well. Then, as I mentioned, we have redesigned the cooling system completely. So traditionally, there would be fans on the shaft, so shaft-driven fans which circulate the air within the generator enclosure. But now we have, in this new generator type, we have added 4 external fans which circulate the air within the cooling air within the generator. And this increases the airflow by roughly 60% within the generator. And this in turn increases the efficiency of the generator and also saves energy when the generator is used less than in continuous operation. And what does that mean? That means that these cooling fans, these can be connected to frequency converters. So then you can run those on demand. So basically, when the generator is running cooler, you can leave those, let's say, off, or then run those at a lower RPM, lower power. So in that way, you save energy also in the cooling system. And this is a redundant system. So like mentioned, there are four fans, 2 on each side, but you can run even if one fan would not be running. You can run the machine with nominal power even with 3 of these cooling fans. And then, as I mentioned, this generator can also be used as synchronous condenser. So what is synchronous condenser? It's not a motor, it's not a generator, it's basically a machine that runs in synchronism with the grid and provides the reactive power and also rotating inertia. Because like Luca also mentioned, energy transition means that there will be a lot solar installed in the networks, a lot of wind. So those power sources don't have this kind of natural inertia which the grid needs to remain in synchronism and operate reliably. So you need many times more inertia to have a reliable network. And then basically, because you have solar, you have wind, if we think about how they produce energy, like solar, of course, when the sun is shining, you don't need this conventional power during those times, other than for peak saving applications. But you need that to balance out the fluctuations of the power supply from the renewables. So the benefit here is that when you can run this new generator as a synchronous condenser, you can then use that to balance the grid or support the grid with more inertia and also the reactive power. It can be either consumed or produced depending on the need. And how that works is that you run the generator to the nominal speed with the engine, and then you decouple the engine and let the generator run as synchronous condenser in the grid. And here are some data about this operation. So inertia constant of this generator can be up to 2.5 seconds. And as mentioned, inertia up to 33,000 kilogram meter squared, and stored energy up to 60 megawatt seconds. So extremely efficient way to support the network. And applications, of course, the normal power grids, but then also data centers, for example, prime power, where you have also the renewable in the power mix, and then weak networks like mining industry, where you don't have that strong network. You might need this kind of grid support functionality. Then lastly, like I already mentioned, the footprint due to the enhanced cooling is optimized, and due to the fact that this is modular construction, also the availability is maximized, because we have ready designed these flywheels and different frame constructions, so that maximizes the availability. And here you can also see a bit better where the flywheels are actually installed. So here on the drive end of the machine, and then there's possibility to have another flywheel in the non-drive end of the generator. So this basically gives the versatility to meet the needs of grid code requirements of today and also tomorrow. Then if we consider the, let's say, other benefits of this new generator type, as mentioned, the efficiency is significantly increased with this new designs. So that, of course, creates an environmental and economic impact. So if we take, for example, a power plant with 20 megawatt engines, the power plant size 5 gensets, so roughly 100 megawatts then in total, natural gas as the fuel for the engines, and consider that efficiency of a typical standard generator would be around 97.7%. This premium efficiency modular generator. Efficiency can be up to 98.2, so 0.5% higher than a typical generator. So that means that you can have 500 kilowatts more of increased energy production with the same engine with these new modular type generators. And then when we consider annual operation hours of this kind of plant for 6,000 hours per year and expected operation life of 20 years with electricity price of 10 cents per kilowatt hours, that basically means that with this 500 kilowatts of increased energy production, you also create energy valued 300,000 USD per year with these assumptions. And then, of course, throughout the lifetime of the power plant, assume 20 years, this means in total 6 million worth of additional energy produced during the lifetime of this power plant. And typical payback time for this kind of premium efficiency modular generator is well below 2 years typically. And then if we go to the environmental impact, of course, when you have higher efficiency, you create more power. These assumptions are exactly the same as in the previous slide. So same power plant with 5 gensets, roughly 100 megawatts. But with this increased efficiency generator, you basically save more than 1 million kilograms of CO2 emissions annually with this high efficiency modular generator, which relates to 255 homes electricity use for 1 year. And then when we consider the whole lifetime of the power plant, it means more than 24 million tons, million kilos of CO2 emissions saved, which in turn equals to more than 5,000 homes electricity consumption for 1 year. So significant improvement, both economically and environmentally. And then, of course, not to mention this kind of ancillary services, what you can do with this generator, like I mentioned, the synchronous condenser use, balancing applications, and peak saving applications in the power network, which of course is additional value for the power plant as such. Good. Then back over to you, Luca.
Oh, thanks a lot, Jari. I was impressed by your slide. So a lot of improvement compared to what we were used to have as in a generator in the past. So I think this kind of development, it's really going to meet the need from the network. So it's really impressive because in my mind I was thinking the old type of generator, and having all these new features on this product development is really impressive. Okay, so let's move to the takeaway message. So I was trying to summarize the main message in 2 slides very shortly. So to come back to the topic, I think it is clear, the demand of electric energy is really growing and booming. I like to use this sentence. So the age of electricity is emerging again. So probably we are really living the time of electric energy. And to me, like I mentioned before, and I want to repeat again this message, is not only transition, but is also addition. So this is really make our life a little we should be more smart, much more smart in what we do and how we set the grid. Then again, connected to this, the grid, the flexibility, and also the speed, how you connect to the grid is clear and need. So we really need to take in consideration that. And a point that is relevant, for sure, the balance, but also we cannot get rid of continuous power and sustainable power when we move in the future. Okay, and I think then to summarize what also Jari was showing, I think the generator is going to play a crucial role in the future in power generation. And I think also is changing the role of the generator, like Jari, you are showing. It's very impressive. And I also impressed by the efficiency, how the impact that the improvement of the efficiency is going to have also in the production of energy. This is unbelievable. And I think the last point is in our company, we do generator more than 100 years. So I think we are probably one of the experts in this area. And we are proud of that. And I think we have very good knowledge about the application and the solution. So we will be very happy, also to provide this kind of service in every place that is needed. I don't know, Jari, if you want to add something. I was trying to summarize, but maybe I missed something, please.
Yeah, thanks, Luca. Did you summarized it well, but maybe just to repeat the topic that energy transition needs new solutions in the let's say generator applications, and this product is to meet those requirements. Be ready for today and also for tomorrow. So that's the key takeaway here.
Oh, very good. Thanks, Jari. I don't know, Sess, if we go back to you for the question and answer.
Yes, we'll now start our Q&A session. Thank you both, thank you Luca and Jari for your informative presentations. Now let's dive into our Q&A. A quick reminder for our attendees, for our audience, to ask questions, simply use the questions widget. Just type them into the box located at the bottom of your screen and click submit. Now we've got some early bird questions already, so let's kick things off with this first question. What is the weight of the flywheels?
Maybe I can take this one. And maybe before I go to the answer, on the slide there is this QR code, which you can use to get into this model, 3D model of the modular generator, and then you can rotate that there in the interface and take a deeper look how the design is. So that maybe also brings up some questions. But the question was, what is the weight of the flywheels, right? Weight of the flywheel. We have different size of flywheels. The maximum weight for the D end is roughly 7,700 kilos, and non-drive end roughly 1,300 kilos. But what is even more important than the weight is the inertia, what is crucial to fulfill the fault right-through requirements in the grid codes, or then for this synchronous condenser applications. So basically, when you have the maximum weight flywheels, the maximum inertia of the generator becomes 33,000 kilogram meters squared. Hopefully that answers your question.
Great, thank you, Jari. Yep, great answer. Now let's move on to the next question. And the next question is, Solar combined with green H2 production for H2-ready gas-fired power plants is not the way to avoid unbalance in the grids. Now that was the question.
Yeah, I can take.
You...
Yeah, I can take. Yes, part of this,
Mhm.
and then maybe Jari, you can add also your view. I think yes, for sure. If we are going to use hydrogen instead of gas in the combined cycle power plant, could be a good option, and I think it can really, give the power that continue power with zero CO2 emission. I think this could be a very good solution. The only problem that we have is that we don't have so much hydrogen today. So I think that could be, something that we should target for the future. And another problem connected to hydrogen production, if we want, for example, go for the green hydrogen, that is mainly based on electrolysis process with the solar energy. Still there, this process is pretty, I would say, not efficient. So the efficiency of the process is not so good. And also the cost is there. So there is a big question mark today. And this is also probably why, this kind of project are not really taking off. Is mainly related to is efficient, is cost efficient. So these are the point. But I think the comment is right. We probably need to find a way to get hydrogen in a good quantity and also at a good cost, using a process that is also respecting, the net zero requirement. So at the moment we are not there. In the future, hopefully, we can have something like that, because for sure, if we can remove gas and we use hydrogen, we can really have a clean continued power supply. So this is my view today. It's a good option, but probably it will take time to reach. I don't know, Jari, if you want to comment, because I think also is a topic that we are in touch already.
I think you summarized it well. But this generator is of course suitable for
yes,
any engine and any fuels that the engine uses. So in that sense, we are ready for anything from the generator.
Yeah, because I think it's also a question of we need more hydrogen, but on the other hand, you really need the hydrogen. How much is the price? So the discussion today is a little bit, unfortunately, on this level. Okay, so and in my view, the cost today, and also the fact that you're going to use a lot of energy with low efficiency process to get the hydrogen to use then to generate other power, it's a little bit, probably we need a little bit more time and think really carefully on this. But okay, this is my view today. So maybe things can change also very fast on that. Yeah.
All right, thank you both for answering that question. Thank you, attendee, for the engaging one. On to the next one. All right, this looks interesting. When will this generator be available?
Maybe I'll take this one. This one as well from the factory side. So basically, this generator is available today. We have already produced these generators, so it's ready and available right away. So just please contact ABB, and we are happy to support you.
Perfect. And a follow-up question to that is the delivery time. Are you able to answer that question for them?
Okay. Yeah, I can continue then, as it's related to the same topic. So delivery time, of course, always depends on the timing and factory loading and that kind of topics. But typical delivery time for this generator type would be around 30 weeks, 25 to 30 weeks on a normal day.
Yeah, one comment about that you already mentioned, Jari, but it's good to repeat. So we developed this solution thinking about modular concept, and like I was saying, the demand is pretty strong, and in some for some industries, the availability is the main issue. So we try to develop this product to really meet this kind of request, strong demand and also availability of the solution in a short time. So we did our best, to really develop our product to maintain this kind of promises and give also the availability of the solution to the most of the customer that they need. Yeah.
Yeah, exactly. The modularity allows that. So there's flexibility basically everywhere due to the modularity. So the applications where the generator can be used and also the availability of the generator.
Fantastic, thank you both. And on to the next one. Again, similar topic about the generators. So are these generators for non-hazardous areas only?
Maybe I take this one. Typically these power plants are non-hazardous areas. The prime mover is usually an engine there, and normally these are installed in a safe area only. So typical power plants, balancing plants, power plants for oil and gas outside the actual hazardous area, mining not in the mine, but there's typically a separate power plant where the gensets are located. So these are, in summary, yes, these are intended mainly for the safe area. So and not the hazardous classified area where there might be gases, for example, present which could ignite.
Wonderful. And on to the next question. So question/statement. They're asking about the firefighting systems associated with the generator. Are you able to elaborate on that a bit more?
Yeah, so generator itself doesn't have a firefighting system. So usually that's then built within the power plant itself. And of course, our generator is compatible with the typical firefighting systems that this kind of power plants, engine power plants have. But the generator itself doesn't have a system. It's part of the power plant then. But very good question.
Okay, thank you for that, attendee. And on a similar topic, we've got an attendee asking about the cooling fans. So can the generator be operated if one cooling fan would fail?
Yeah, I can take that. Yeah, that's related to the reliability of this generator as well. And like mentioned, it has 4 cooling fans to circulate the cooling air and distribute it around the generator. But we have designed the system so that one of those cooling fans can be out of operation, and still with the 3 fans you can have nominal output of of this generator. So that has been considered within the design.
Fantastic. And as we're almost to the end of our time, I'll ask this final question to you both, and that is, how do you control the cooling fans?
Luca, who will take it?
I will leave to you. You are the specialist, Jari. So.
Okay. Yeah. So basically, you have two options how to control the cooling fans. One is traditionally, so plug those directly into the network and run them as direct online. But then the let's say more efficient solution is to have frequency converters for these cooling fans, and then you can control the speed and availability of these cooling fans. Because like mentioned, one benefit of this system is that, for example, if you run a shorter time the generator, or for example, if the ambient temperature is cooler than nominal, then you can run up to a certain temperature even without the cooling fans, and then gradually start to rotate them or operate them, and we can provide those let's say operation models for the frequency converters there, or even supply the frequency converters to these cooling fans. So that's the principle there. Thanks for asking.
Well, fantastic. Fantastic insights, Luca and Jari, and thank you both for addressing so many of these great questions. Now, as we approach the end of today's session, we'll need to wrap up our Q&A. But if we didn't get to your questions, don't worry. Our speakers and team will follow up with you offline after the webinar. And that brings us to the end of today's webinar. A huge thank you to Luca and Jari for sharing their expert insights, and to our sponsor, ABB Motion High Power, for making this session possible. To all our attendees, keep an eye out on your email for details on how to access the on-demand version of this webinar, and you can also find it on our website. The presentation slides will be available for download as a PDF once the webinar goes live on demand, and we'd also really appreciate it if you could take a moment to complete the post-webinar survey. Feedback will help us make future sessions even better. Now, stay connected with us for more exciting webinars. Follow us on X and our LinkedIn company page at BTMI Webinars for daily updates and upcoming webinar announcements. Once again, thank you for joining us today, and I wish you a wonderful day ahead.
Thank you very much. Bye-bye.
Thank you.